Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we completed with modes of convergences, and today we'll be starting with the new topic of paper one of statistics, paper one of ISS examination, which will be correlation. Those who are willing to give the exam this year, they might revise with us on this topic, and those who are wanting to give the exam in the next year, which is 2027, they can start with us today for the paper one and can see our other lecture videos. And if you are very interested and you are very willing to give your 2027 examination, then we have launched our batch Lakshya 2027, in which you can enroll and ask us any queries about it. Whatever you want to ask, we are always available for you. In the description there has been our WhatsApp number. You can ask us on that. Moving back to the topic, today we will be starting with correlation. So when we say when we say correlation, by the word correlation we can denote what is the relation, right? We can say what is the relation. If I am having two variables, suppose I am having x and y. If x increases when y increases, or if x increases then y decreases, these are the term that say that gives us the way that x is related to y. X, or because they are two variables, so we can say x is correlated to y. When x is increasing, y is also increasing, and when x is increasing, y is also decreasing. So there are two types of correlation. One is positive correlation, and the second one is negative correlation. What is positive and negative? When one of the quantity or the variable increases and the other one also increases with that, then both of the variables have positive correlation between them. And when one of the variable is increasing and the other one is decreasing, then we can say that these both variables have negative correlation between them. So this is what correlation is all about. We can also make graphs and everything to show. Suppose we have x and y, and the data is distributed like this. So here we can see that when x is increasing, y is also increasing, but not in a constant manner. It is increasing at large. So we can say it is a positive correlation but not direct relation. Okay. And when I say that x is increasing when y is increasing with this, we can say that there is a linear relationship between x and y. As x increases, y is also increasing, which means that it has a positive correlation with a linear relationship. These are the kind of things that we have done in econometrics, and if you haven't seen that video, you can rewatch that video of in paper 3. Now moving forward, we today will be dealing with the topic Carl Pearson's correlation coefficient. The most important topic that has been asked multiple number of times in our previous year questions is Carl Pearson's correlation coefficient. When we say Carl Pearson's correlation coefficient, we denote it by R and the two variables x and y. The correlation coefficient between x and y and the coefficient is denoted by R. When we say the Carl Pearson correlation coefficient, it is equals to covariance between x and y upon standard deviation of x into standard deviation of y, or we can also write it as under root of variance of x into variance of y. This is our Carl Pearson's correlation coefficient. Now this can be written this can has one more denotation. when we have been given different types of things. So when we do it, it will be summation of xy n into summation of xy minus summation x summation y upon under root of n summation x square minus summation x whole square into n summation y square minus summation y whole square. This is our second denotation of Karl Pearson's correlation coefficient. The second one has been least asked in the examination. The first one has been mostly asked. So let us move. What are the properties of Karl Pearson's theorem, correlation coefficient? The first and the most important property is that this Karl Pearson correlation coefficient always lies between 1 and -1. This is the most important property. They can directly ask you this: what are the limits of Karl Pearson's correlation coefficient? Then the second one is that it is independent of change of scale, but sorry, it is independent of change of origin, but not of scale. Okay, how do we do that? If we have two variables x and y, and if we denote u is equals to x minus a upon h, and v is equals to y minus b upon k, then we can say that r of xy is equals to h into k upon modulus of h into k r of uv. This is how we denote it, because it is independent of origin, so a and b are useless for us, but it is not independent of scale, so h and k are useful for us for calculating purposes. Okay, these were the properties of our Karl Pearson's correlation coefficient. Now moving forward to some of the PYQs that has been asked in the examination. So this is our first PYQ. The coefficient of correlation between x and y has been given. So the coefficient is given, which is rxy is equals to 0.6. The covariance is 4.8. So covariance between x and y is given as 4.8. If the variance of x, so variance of x has been also given as 9. What do we have to calculate? The standard deviation of y. So our formula is rxy is equals to covariance between x and y upon standard deviation of x into standard deviation of y. From this, if we have to calculate standard deviation of y, it will be covariance upon standard deviation of x, which will become 3, and co rxy. When we cancel all of them out, it will be 6 8s are 48, 8 by 3. When we divide 8 by 3, it will be 2.67, which is our option number D. Direct method has been used, direct formula has been used in this question. So this is how we can solve it in examination. So this was our ISS PYQ for 2019. Now moving forward to the next PYQ on the same topic. Here, this is, let x be a random variable with finite variance x, the sigma square. So we have been given variance of x as sigma square, and y has been given as 20 minus x. Then the coefficient correlation between x and x plus y into x. So from this we can say that x plus y is equals to nothing but 20. From this equation we have denoted this. Now for correlation coefficient between x plus x and x plus y into x, it will be if I say r, then this will be covariance between both of them. Covariance between both of them, x into x plus y into x will be written as 20x upon variance of x into variance of 20x, standard deviation of x into upon standard deviation of 20x. So first of all, we have to find what is the covariance between x and 20x. So whenever we have to find covariance between two variables, it will be covariance between x and 20x can be written as 20 taken outside, covariance between x and x. And covariance between x and x is nothing but variance of x. So it will be 20 sigma x square or sigma square. Simply let us take sigma square, which is given. Now variance of x. Variance of x is equals to sigma square, which is given. Variance of 20x will be equal to 20 square, which will be 400 into variance of x, which is sigma square. So these are the derivations that we need. Covariance between x and 2x is 20 sigma square. We can directly write this upon standard deviation of x is sigma square, under root of sigma square, which will be sigma only, and standard deviation of 20x will be under root of this, which will be 20 into sigma. So this sigma and sigma gets cancelled with this sigma, and 20 also get cancelled. And what are we left with? We are left with 1. So option number D is the correct answer, which is 1, which is the correlation coefficient between x and x plus y into x. This is how we attempt the question. It was directly a direct application of the formula. Now moving forward with the next question. Here they have given us that if d x minus y is d has been given as x minus y, and variance of d is sx square plus xy square, then the correlation coefficient between xy. So if we calculate, d has been given as x minus y, so if we calculate variance of d, it will be equal to variance of x minus y, which will be equal to variance of x plus variance of y minus 2 into covariance of x and y. Okay, this will be our answer. So variance of d, they have denoted it as sd square equal to sx square, which is variance of y, sy square minus 2 into covariance of x and y. Here, as we compare these two formula, this formula is the square ones and this one. When we are comparing these two formula, we can see that there is no covariance term there. So from here we can, as on comparing these two equations, we can say that minus 2 covariance x comma y is nothing but equal to 0. So covariance between x and y will be equal to 0. Now we have to find out the correlation coefficient between x and y. Correlation coefficient between x and y is nothing but covariance between x and y upon standard deviation of x into standard deviation of y. Covariance is 0. So 0 upon anything will be 0 only. So our answer will be equal to 0. Option number C. This was asked in ISS 20 Statistics 2020 paper, and this is how we attempt the question. Now moving forward to another PYQ. This is the application of your second property, which is the independence or dependence on scale and origin. So here R is the correlation coefficient between two random variables. So R x y has been given to us as R, and we have been given another variable z is equals to z, z is equals to ay plus b, where A is not equals to 0 and B belongs to any real number. Then the correlation coefficient between X and Z. So they have asked us this. Now they have given us correlation coefficient between X and Z. So if we have to calculate correlation coefficient between X and Z, it will be covariance between X and Z upon standard deviation of X into standard deviation of Z, right? So from here we can say the first of all let us calculate for covariance. Covariance between X and what is the value of Z? It will be AY plus B. Whenever we calculate this, it will be A into covariance of X and Y. Okay. So covariance between X and Z will be A into covariance of X and Y, and standard deviation of X, let us say that it is equal to standard deviation of X only, and standard deviation of Z will be, or we can say that variance of Z is equals to variance of AY plus B. When we take it as variance, it will be A square into variance of Y, which we can denote it as A square into sigma Y square. Okay, so this is how we denote it. Now we have been given Rxy is equals to covariance between X and Y upon sigma X into sigma Y, and Rxz, which is equals to covariance of X and Z. Covariance of X and Z can be written as A into covariance between X and Y. This we have denoted here from this statement. Now sigma Z, sigma x can be written as sigma x, and sigma y can be written as modulus of A. When it comes out of the under root, it will be modulus of A sigma y. Okay. Now as you can see in here that this can be written as A upon modulus of A into covariance of X and Y upon sigma X into sigma Y. Now this thing, this whole box is nothing but equal to our R xy, right? So and R xy is equals to R. So from here, instead of writing this whole big box, we can just write into R. So the correlation coefficient between X and Z is A upon modulus of A into R, which is our option number D. Okay, this is how we solve them, and this is one of the results of the corollary of that second part. So these should be remembered by heart. Instead of calculating and wasting your time in the examination, you can directly just tick the answer and move forward. Now moving forward to our last question, which has also been a part of our PYQ series of statistics 2019. In here, they have given us four uncorrelated variables, which means covariance between xi and xj. Any two x is equals to 0 for all I not equals to j, and they all goes from 1 to 4. Okay, each with variance, and all the variances of xi. Variances of xi is equals to sigma square for all I goes from 1 to 4. Then the correlation coefficient between u and v. U have been given to us as x1 plus x2 plus x3, and v have been given to us as x1 plus x2 plus x4. Now for correlation coefficient, first of all we have to calculate covariance and covariances. So let us first calculate covariance between u and v. Whenever we have to calculate covariance between u and v, it will be x1 plus x2 plus x3 into x1 plus x2 plus x4. So each one will be covariated with the next one. So it will be covariance. First of all, x1 will be covariated with x1, x1, x1 plus covariance of x1 with x2 this with this with this with this. This is how we are doing. Plus covariance between x1 and x4. Plus the second one, covariance between x2 and x1 plus covariance between x2 and x2 plus covariance between x2 and x4. Then again, covariance between x3, x1, covariance between x2, x3, x2 plus covariance between x3, x4. Now we know that whenever these two I and j are not equal, the covariance is equals to 0. So all that those are not equal can be written as 0. Just like this is covariance between x3 and x4. 3 and 4 are not equal, so it will be 0. 3 and 2 are not equal 0. 3 and 1 not equal 0. 2 and 4 not equal 0. 1 and 4 not equal 0. 1 and 2 not equal 0. And this is 2 and 1 not equal 0. So we are only left with these two, which is covariance between x1 x1 and covariance between x2 x2, which is nothing but variance of x1 and variance of x2. So instead of them we can just write it as variance of x1 plus variance of x2. And we know that for all xi's variance is equals, variance is same, it is sigma square plus sigma square, which can be written as 2 sigma square. Now moving forward with the variance. Variance of u, which is variance of x1 plus x2 plus x3. Now this also has formula, variance of x1 plus variance of x2 plus variance of x3. Okay, let me write it as variance of x1 plus variance of x2 plus variance of x3 plus covariance of x1 x2 x2 x3 x2 x1 x3, like this. But all the covariances are 0, so I'm not writing that. So variance of this are all going to be same, so and these are 3 terms, so it will be 3 sigma square. And similarly, variance of v will be equal to variance of x1 plus variance of x2 plus variance of x4. And when we open it as, it will also be 3 sigma square. Okay. Now what is the correlation coefficient between these u and v? It will be covariance between u and v upon standard deviation of u into standard deviation of v. Covariance between u and v is 2 sigma square upon standard deviation of u is 3 sigma square under root of 3 sigma, and standard deviation of v is also under root of 3 into sigma. These sigma get cancelled and root 3 will become 3. So r uv, which is the correlation coefficient between u and v, we get it as 2 by 3, which is the option hasn't been given here, but the option will be this 2 by 3. So this was also your PYQ of 2019, and I hope that you have understood how do we calculate for correlation coefficient, and what are the properties and how do we solve it in examination. And if you still have any doubt, you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best and thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.